Run AI models with IBM Watson Studio. About this course. Do you think you can build an artificial intelligence model in IBM Watson Studio? Can you run the model and observe how its AI algorithms analyze data? Can you harvest predictions from those operations? Welcome to the Run AI Models with IBM Watson Studio course. In this course, you'll practice creating an AI machine learning model in a series of simulations, using IBM Watson Studio. Learning objectives. After completing this course, you should be able to describe machine learning algorithms and models. Explain the purpose of IBM Watson Studio. Describe the key features and benefits of IBM Watson Studio. Set up a machine learning project in IBM Watson Studio. Create a cloud object storage resource. Import a data set into IBM Watson Studio. Build an AI model using AutoAI in IBM Watson Studio. Run a prediction experiment for an AI model. Explain the confusion matrix. Save a model as a Jupyter Notebook. Download a notebook in Jupyter Notebook, .ipinb, format. About this module. Module 1. Introducing IBM Watson Studio. Introduction. In this module, you'll learn about how IBM Watson Studio uses algorithms and data sets to create machine learning models. Learning objectives. After completing this module, you should be able to describe machine learning algorithms and models. Explain the purpose of IBM Watson Studio. Describe the key features and benefits of IBM Watson Studio. Machine learning models. Machine learning is, in the end, about making predictions using statistics and calculus, both of which are used in bits of code called machine learning algorithms. These bits of code, in turn, can be organized in large-scale computer programs called machine learning models. Your understanding of machine learning and how it's executed in IBM Watson Studio starts with an exploration of these two concepts. Machine learning algorithm. A machine learning algorithm is a set of program code. If you've ever worked with code, you might know what a function is. A function is a set of logical operations that inputs some sort of data, analyzes or transforms it, and then outputs a result. But in a machine learning algorithm, that analysis often has a specific goal, to recognize patterns in data sets. For example, an algorithm in an AI weather prediction system might ingest a series of sunlight measurements and water temperatures, then analyze and output a pattern describing how these factors appear to influence each other. Machine learning model. A machine learning model is a group of machine learning algorithms. Operating together, they detect patterns among their algorithms' output and use those patterns to make predictions. For example, a model whose algorithms look at patterns regarding temperature, climate, geography, and so on might predict a rainy day next Saturday. How is this different from the way conventional computer programs operate? A machine learning model doesn't depend only on a human to write its code or to adjust its programming if its predictions aren't right. Instead, a machine learning model can reprogram itself. So if, for example, a weather model tends to get a certain type of prediction wrong, it can adjust its algorithms, weights and biases, statistical constructs, to improve the accuracy of its predictions. Why are you learning about this? Because creating machine learning models is the primary job of IBM Watson Studio. Its integrated development environment, IDE, makes this difficult task easier, faster, and more affordable. This is the future of computer programming. Early model development problems. Watson Studio was born from a need. Until about 2015, artificial intelligence scientists found that building AI systems was cumbersome and time-consuming. They might need to search the web, review components, hand-code connections to big data tools and learn to use them, and more. This was an expensive problem for laboratories and companies trying to develop and market useful systems. Even worse, working with AI broke up workflows. Developers toggled from one technology to another, jumping back and forth between workspaces, and repeatedly switching programming tools to get tasks done. These problems slowed down the adoption of AI systems, making it hard to integrate them into existing technology such as medical care or automobiles. Once all the elements were working together and launched, it was difficult to provide support when help was needed. The IBM Watson Studio solution. IBM Watson Studio fulfills the need. IBM's Watson Studio solution is what researchers call an integrated development environment, IDE. Named after IBM's founder, it pulls together the most useful development and analytic tools, wrapping them in a development platform that is powerful enough to meet large-scale challenges, yet simple enough that developers can master it quickly. IBM Watson Studio solves AI development problems. With IBM Watson Studio, businesses can simplify data projects with a streamlined process to extract insights from data to help them get smarter faster. It delivers an easy-to-use, collaborative data science and machine learning environment to build and train models, prepare and analyze data, and share insights all in one place. IBM Watson Studio is a single environment for sharing work to solve problems within the system, rather than starting from scratch every time a new issue arises. And developers can use that efficiency to quickly dive into building machine learning and deep learning algorithms. Watson Studio gives developers a collaborative data science and machine learning environment, easy visualizations with drag-and-drop code, an efficient workflow, a built-in neural network modeler, open-source tools such as Jupyter Notebooks and RStudio. Watson Studio's features sound impressive. But do they really make a difference? Read on to learn how they help developers working on real-world projects. Integrated Development Environment. IBM Watson Studio helps developers collaborate and visualize their work. Try working through this short case study. Imagine that you're overseeing a team of developers working on a healthcare AI system. The project is running behind schedule and over budget. You need to solve 3 problems to bring it back on track. Don't worry if you get this wrong the first time. Just try again. Watson Studio could solve these problems. It's an IDE that gives developers the tools they need, in a coordinated workspace where they can get things done together. Typical tools and dashboards. IBM Watson Studio speeds data input and insights output. Watson Studio is more than a collection of resources that can communicate with each other. It eases ingesting data into an AI system, organizes assets, performs complex analysis, and displays results that make complicated issues simpler to understand. Select each section to sample some of Watson Studio's capabilities. Automated data preparation. IBM Watson Studio has a feature called AutoAI that prepares raw data for machine learning. It can apply various algorithms to clean and structure the data, automatically select an appropriate model, and optimize its output for the fastest, most useful output. Visual neural network design. Watson Studio helps developers create machine learning flows and design neural networks visually, using a simple drag-and-drop interface and open-source code libraries. Sophisticated analysis and prediction. Watson Studio recommends algorithms and uses the latest neural networks to predict and build patterns. It helps programmers create visualizations simply by selecting data items, after which the system itself can choose the best way to visualize its findings. Unified dashboard displays. Watson Studio dashboards not only visualize the results of complex analyses, they also gather related views on data into a single place where clients can find and understand the information they seek. These dashboards don't require specialized coding or database skills, and researchers can easily share them across the Internet. IBM Watson Studio is designed to make data science a team sport that helps developers learn, create, and collaborate on great machine learning models. Can you identify ways it fulfills these goals? Putting Watson Studio models to work. When a classical computer program is not enough. Today businesses, industries, and governments need more computing power than seemed enough just a few years ago. They depend on data analysis that can only be developed from machine learning models, using tools like IBM Watson Studio. Person wearing white and blue Air Jordan 1s. Consider, for example, the problem faced by a sneaker manufacturer that wants to know what customers think and say about its products. This information could help it plan product distribution for today and keep up with new trends in the future. The best way to discover these things might be to study product reviews people have posted, and also study IM texts sent by the manufacturer's teen and young adult customers. What are they saying? What do they love or hate? What new thing did they just see that they really want to buy? Here are some of the things that make this discovery difficult. Millions of social media posts hit the internet every hour across Twitter, TikTok, and others. Those posts cover zillions of topics, most of which have nothing to do with sneakers. Posts that do mention sneakers might do so in countless different contexts. Even if a conventional computer could be programmed and given enormous resources to keep up with this flood of data, sneaker fashions change without warning, and those changes cannot be predicted or prepared for with traditional program code. But with IBM Watson Studio, a modest-sized team of specialists could build a machine learning model that will, as time goes by, get better and better at spotting major trends in sneaker design. It could even follow celebrity fashions, then begin predicting new trends more and more effectively. About this module. Module 2. Prepare your machine learning project. Introduction. Now, let's get ready to simulate building an AI model with IBM Watson Studio. In this module, you will learn about the scenario for your project. You'll also get practice in a simulation to set up a new project in IBM Watson Studio and import data. Learning objectives. After completing this module, you should be able to set up a machine learning project in IBM Watson Studio. Create a cloud object storage resource. Import a data set into IBM Watson Studio. Your AI machine learning project. Imagine that you're an up-and-coming coder looking for your big break. Yesterday, you got a phone call from a major bank in Germany. A few hours later you found yourself flying across the ocean on a transcontinental jet. This could be your chance to make your name in AI machine learning. You leaned your seat forward and studied the materials that the bank sent you. Gray and red airliner wing. A terrific opportunity. The bank wants to protect itself from the risk of making loans that are never repaid. It's preparing to launch a new website on which customers can submit requests for loans up to €10,000 and, if their credit is sound, get instant approval. The good news is that this will attract customers who want to apply for loans quickly, without a lot of fuss. The bad news is that it will give the bank almost no time to investigate each applicant's credit risk, then reject those who might default on their loan, ultimately costing the bank millions of euros. The bank wants you to lead the development of an AI machine learning system that can rapidly predict the risk of granting a loan for each customer who applies. The scope of your experiment. Using simulations of IBM Watson Studio, you'll build an AI machine learning model, train algorithms on the same data set of bank loans and defaults, then test them competitively, using additional data, to see which predicts defaults most accurately. Your data set. You'll use data from a real German bank that's fictionalized for this simulation. The file contains records of 5,000 past loans. Each record includes ample data such as the customer's credit rating, bank account balances, loan purpose, and more, and whether the borrower paid or defaulted on the loan. Your to-do list. Using IBM Watson Studio and a data set, you will simulate the following steps. Set up a new project in IBM Watson Studio. Create a learning model designed to predict whether an applicant is more likely to pay back or default on a loan. Train your model on 90% of your data set, including loan outcomes. Test the model on a test set of data, the remaining 10% of the data in the data set, to see which algorithm gives the best predictions. Save the final model with highest confidence as a Jupyter Notebook. Important note: you do not need to download the spreadsheet of data, access IBM Cloud, or work in IBM Watson Studio to complete this course. You'll use the following simulations to practice the steps and learn in a safe, pretend environment. Let's get started. Today, you find yourself in the offices of the German bank, with several of their IT specialists looking over your shoulder. It's time to show them how you work. Simulation: start your project and upload data. In this simulation, you're going to use IBM Watson Studio to perform the steps to start a new project, then upload the data set of past loans and their outcomes. There are 27 steps to complete. Reminder: you do not need to access IBM Cloud or work in IBM Watson Studio to complete this course. You'll use the following simulation to practice the steps and learn in a safe, pretend environment. Simulation transcript. Start a project and upload data. 1. After you log into IBM Cloud, you'll find the dashboard. This dashboard lets you access the tools, services, resources, and more in your IBM Cloud account. Select Catalog on the top toolbar. The IBM Cloud dashboard. With several bank IT workers looking on, you log into IBM Cloud. As it comes up, you explain that you can access Watson Studio in just a few steps through an IBM Cloud account. This acts as your doorway to amazing AI resources. 2. This is the catalog of IBM products and services. It is a best practice to create database storage. First, type object storage in the search field and select Enter. 3. Select object storage. 4. For this simulation, you are using a free account, so you don't need to review a pricing plan. Select the next arrow to continue. 5. Scroll down to the Configure Your Resource section. Developers would say that you're going to provision the object storage. A service name is automatically generated, but you should name it something meaningful to your project. Type Cloud Object Storage risk_fraud in the service name field and select Enter. 6. You don't need to fill out the other fields. In the lower right, select Create. 7. Now that you've provisioned the cloud object storage, select the sandwich icon at the top left to display the navigation menu. 8. Select Resource List from the navigation menu. 9. This displays a list of the resources that you have created. Select Storage to see that the cloud object storage _risk_fraud that you just created is listed. 10. Select Catalog on the top toolbar. 11. Notice on the left side under Category that there is a large collection of available tools. Select the AI/machine learning category. An AI/machine learning service. Now you're through the IBM doorway. You've finished basic bookkeeping and you're ready to set up a project in IBM Watson Studio. Some of the IT folks haven't seen anything like this before, so more of them crowd around to watch you get ready. 12. Notice there are several AI and machine learning products listed. Find and select the Watson Studio block. 13. For this simulation, you are using a free account, so you don't need to review a pricing plan. Note that the location selected is Dallas, US South. Scroll down to reveal the Configure Your Resource section, then select the next arrow to continue. 14. Under the Configure Your Resource section, the service name is automatically generated. In this case, Watson Studio DL. Type Watson Studio AI Fundamentals in the service name field and select Enter. 15. You don't need to fill out the other fields. In the lower right, assume that you've checked that you have read and agree to the license agreements, then select Create. 16. You've provisioned the IBM Watson Studio service. Notice the service name you picked displays in the upper left. Now, you need to create a new project. Select Launch in IBM Cloud Pack 4. Data. 17. On the Build and Manage ML Models pop-up, Provision Watson Machine Learning is select by default. Select Next. A new AI project. With your service set up, you'll create the AI project itself. This involves launching it, naming it, and associating it with the database that you'll use to test your machine learning models. 18. Make sure that Dallas displays in the Select a Region field. Since Dallas was selected for Watson Studio, you must make sure that you select Dallas for all the other services. Select the next arrow to continue. 19. Under the Configure Your Resource section, name your service. Type Machine Learning risk_fraud in the service name field. Then select Create. 20. You are working on a new project, so select New Project to create an empty project and then select Next. 21. Under the Define Details section, you can name your project. Type risk_fraud in the name field. Select the next arrow to continue. 22. Notice under Storage that IBM Watson Studio already provisioned the Cloud Object Storage COS that you created earlier, so you have a database. This COS can store unstructured data like images and text. Soon, you'll work with structured data in a comma-separated values CSV file. Select Create. 23. You've created the project. This is the IBM Watson Studio Projects dashboard. You can see your project name at the top. This is the Overview tab. Select the Assets tab. 24. It's time to upload your data set. Select Drop Data Files here to open your local drive and find the German_credit_data_biased_training.csv file that you'll be working with for the project. 25. Drag and drop the German_credit_data_biased_training.csv file to drop data files or browse for files to upload under data in this project. 26. Notice your CSV file is right there for you. Select German_credit_data_biased_training.csv. 27. A Preview Assets page opens so you can now preview your data. Take a moment to check out the data that displays. Select the next arrow to continue. Conclusion: you successfully provisioned the IBM Watson Studio service, set up a new project, and uploaded the dataset to your project so you're ready to begin working with it. Good work so far. You've completed your initial setup and are ready to create the actual experiment. You provisioned IBM Watson Studio as a service. You created a new project. You uploaded the data about past loans and defaults that you'll use for machine learning training. Let's review your steps with a short quiz to remind you of what you accomplished. About this module. Module 3. Conduct your machine learning project. Introduction. In this module, you'll practice building an AI model, training it on German bank data, and then running it to generate predictions. Learning objectives. After completing this module, you should be able to build an AI model using AutoAI in IBM Watson Studio. Run a prediction experiment for an AI model. Explain the confusion matrix. Simulation, configure and run your project. You take a short break and chat with members of the German bank's IT department. So far, they admire your work. Now you return to the project. It's time to begin running it. You've done well so far, and bank management is eager to see what you can accomplish. Now you begin the most vital of your project, setting up 4 algorithms and running them in competition. It will enable you to recommend the best system to your client, potentially saving them millions of euros in defaulted loans. Without IBM Watson Studio, this could be a lot of work. But Watson Studio's integrated development environment will help you move through the process. In this simulation, you're going to use IBM Watson Studio to configure your AI model, then run them competitively to see which most accurately predicts risky loans. There are 31 steps to complete. Reminder: you do not need to access IBM Cloud or work in IBM Watson Studio to complete this course. You'll use the following simulation to practice the steps and learn in a safe, pretend environment. Simulation storyboard. Create and run AI models. 1. Now that you've set up your dataset in cloud storage, it is time to build the AI models. Select New Asset. Start creating your AI model. AI models. Creating artificial intelligence models used to be an incredibly complex and difficult task. But today you can show off to your colleagues how IBM Watson Studio does this for you automatically. 2. On the left side, there is a tool type list. Select the Automated Builders tool. AutoAI is the only automated builder displayed. With AutoAI, you will be able to quickly set up and run AI models, using your data to train and test the models. Select AutoAI. 3. Creating and testing AI models is called experimenting. Now it's time to create your AutoAI experiment. Type loan risk in the name field to name your model and press enter. 4. In the Define Configuration section, you'll see a machine learning service isn't associated with your project yet. Let's take care of that now. Select the Associate a Machine Learning Service instance. Link. 5. On the Associate Service page you'll see all the services you've created that can be associated with your experiment. Right now, there's only one service displayed, Machine Learning Risk_Fraud. Select the checkbox next to the service and then select Associate. 6. Now that you've associated your machine learning service, select Reload to refresh the page. 7. You can see Machine Learning Risk_Fraud displayed in the Watson Machine Learning Service instance field now. You're ready to create your AutoAI experiment. Select Create. 8. It's time to add your data source. Select from project to find the data source you added previously. Your experiment. You promised the bank you'd run several different machine learning algorithms competitively. You'd train them all on the same partial set of historic data about people who took out loans and then paid them back or defaulted on them. Then you'd test how well they performed, based on what they'd learned, by feeding them identical sets of new data, without telling them who defaulted. Each algorithm would make predictions about everyone in the new data set, classifying people as risk or no risk. 9. On the left, you'll see categories listed. Select Data Asset to reveal your data assets. 10. You can see your data asset. Select the checkbox next to German_credit_data_training.csv. 11. On the right, information about the asset is displayed including name, asset type, size, and when it was modified and created. Select Asset. 12. Now it's time to configure the details for your experiment. The first question that displays asks if you want to create a time series forecast. For this experiment, you don't want to do that, so select No. 13. The next question that displays asks what you want to predict. This is asking what column from your data set you want the AI model to predict. Select Prediction Columns to open the drop-down list. 14. Next to risk are the letters str. This indicates that the data type in the risk column is a string. Strings are a sequence of letters, digits, punctuation, and so on. In this case, it's text data. Since you're trying to predict which individuals are good risks for loans, select Risk. 15. The prediction type that Watson AutoAI selected is binary classification. You're trying to determine whether an individual presents a risk or no risk, which is a classification with only two options, so leave the prediction type as binary classification. Select the next arrow to continue. 16. By default, accuracy and runtime is selected in the optimized for field. This means when Watson is evaluating which algorithm is best, it will optimize by balancing accuracy and speed. Select Experiment Settings to make further changes. 17. This is the General tab. It shows what you selected on the previous page. Binary classification is the prediction type, no risk is the positive class, and accuracy is the optimize metric. Select the next arrow to continue. Competitive algorithms. Some folks watching you had expected you to create mathematical algorithms that could analyze data and predict credit risk. It's time to astonish them. How? By using Watson Studios to line them up quickly. 18. Scroll down to view the algorithms to include section. Notice gradient boosting classifier is not selected. Select the checkbox next to gradient boosting classifier. 19. Scroll down to view the algorithms to use section. Watson AutoAI lets you test up to 4 algorithms. Select the next arrow to continue. 20. By default, Watson will select the best 2 algorithms to test on the data. Select data source from the left menu. 21. Scroll down to view the training and holdout method section. The training data split slider lets you choose how much of the data set to use for training and how much to use for testing. By default, 90% of the data set is used for training and 10% of the data set is used to test how the AI model is performing. Hover over the underlined words to see more about each field in this section. 22. Below the training data split is the select features to include section. Here, you can select which columns, or features, in the data set to use for training and testing. There are 3 pages of data. Select the forward arrow to page through the columns in the data set. 23. All the features in the data set are available except risk because that's what is being tested. By default, all the features are selected. Select the checkbox next to telephone to deselect it and not use this feature in the experiment. 24. Select Save Settings to confirm all your choices. 25. Everything is set up. Select Run Experimento. Start the experiment. Launch time. You're about to launch the experiment. Your models will ingest the historic training data. Then run the new data and make their predictions. Like people watching a horse race. Everyone leans in to see what happens. 26. The relationship map shows by default. Select the swap view link under Progress Map to display the progress map. 27. Here, the progress map shows the 2 models that are being tested. Take a moment to review. Select the next arrow to continue. 28. Watch as the AutoAI experiment runs. This will only take 45 seconds, but would take roughly 5 minutes when performed in the live environment. 29. Notice that each model has 4 pipelines, or algorithms, for a total of 8 pipelines. The pipeline that's producing the most accurate predictions and is the fastest is shown with a star. Select the pipeline with the star. 30. This displays the pipeline details. By default, the ROC curve is shown. Select Confusion Matrix from the model viewer on the left. 31. This displays the confusion matrix. You will learn more about the confusion matrix and what it means next. Conclusion: you successfully ran an AutoAI experiment in IBM Watson Studio. You determined which of the 8 pipelines makes the most accurate predictions based on the data set and generated a confusion matrix. Well done! You created an AI model with 4 algorithms, trained them on the bank's data set, then ran each algorithm to get the predictions about which applicants were likely to default on their loans. Now, you need to look at the output from your AI model and see how well it did. Understand the confusion matrix. The AutoAI service has generated a winning pipeline. When you selected that pipeline, you were able to bring up information about it, including the confusion matrix. The confusion matrix allows you to measure the performance of your model. Let's take a look. Zoom in to examine closely. In the graphic you can see that the model has an accuracy rating of 0.784 on the holdout data. That means, about 78% of the time, the model accurately predicts whether someone is a good risk for a loan. About 22% of the time, the model makes an inaccurate prediction. That's valuable information. But that's just the overview. What kind of mistakes is the AI making? That's where the confusion matrix comes in. The confusion matrix is a visual representation of performance of the AI model. It looks at the observed versus predicted results. Terms. To understand the confusion matrix, you'll need to understand some terms first. True positive. The model predicts positive risk, and the result is positive risk. False positive. The model predicts positive risk, but the result is negative, no risk. False negative. The model predicts negative, no risk, and the result is positive risk. True negative. The model predicts negative, no risk, and the result is negative, no risk. Results. Now that you understand the structure of the confusion matrix, let's look at the confusion matrix your experiment generated. IBM Watson color codes the confusion matrix to make it easier to read. Green indicates more correct and blue indicates less correct. What can you conclude? The green shading on the true positive and true negative cells tells you that your model is very good at predicting no risk when the person is not a risk, true positive, and risk when the person is a risk, true negative. However, the AI model isn't quite as good when it comes to false positives, predicting someone is a risk when they are not a risk, and false negatives, predicting someone is no risk when they are a risk. The team is impressed with the speed and the accuracy of the model. Their biggest question is how to make the model more accurate. You consider this and tell them that the data set you used to build the model was small and with more training, the AI model should become more accurate. The team starts to smile. There is plenty of data in their records, they're anxious to get the model and start working with it. Great work! You created an AI model with 4 algorithms, trained them on the bank's data set, then ran each algorithm to get the predictions about which applicants were likely to default on their loans. This was complicated work. So you gather your IT colleagues around you and walk them through a quick review of your steps. You used AutoAI to build your models, associating them with the machine learning service you created earlier. You created an experiment, attaching and configuring your data. You selected a predictable column in the dataset as your x-axis. You ran the experiment. You displayed the confusion matrix, ready to implement in the last part of your process. Let's review your steps with a short quiz to remind you of what you accomplished. About this module. Module 4. Save your AI model. Introduction. In this module, you'll practice saving the most effective model as a Jupyter Notebook, allowing you to use your AI model with different data sets, edit its algorithms, and more. Learning objectives. After completing this module, you should be able to save a model as a Jupyter Notebook. Download a notebook in Jupyter Notebook, .ipinb format. Simulation, save your model as a Jupyter Notebook. After a short lunch break with your colleagues, the team returns with you to your workstation. It's time to finish your project. Thanks to the AutoAI in Watson Studio, you now have a working risk prediction model. AutoAI used the data you provided to train and test the different algorithms and determined which was the best at predicting risk. All you had to do was set up the experiment and let Watson do all the hard work. Now you'll finish by showing the bank's IT team how to save the AI model as Jupyter Notebook. Jupyter Notebooks allow you to collect all aspects of your project in one place, including code, graphics, text, and the output of the model. This makes it easier to provide all the information necessary to the project in one place. Jupyter Notebooks also provide others with a way to view, edit, and collaborate on your AI model over the Internet. In this simulation, you're going to use IBM Watson Studio to save the most effective model and convert it to an editable Jupyter Notebook. There are 12 steps to complete. Reminder: you do not need to access IBM Cloud or work in IBM Watson Studio to complete this course. You'll use the following simulation to practice the steps and learn in a safe, pretend environment. Simulation transcript: save AI models as Jupyter Notebooks 1. Once you have completed your experiment and determined the best model, your next step is to save the model. Select Save As Models and Notebooks. You'll recall that the experiment ended by showing a confusion matrix. It's a mathematical test that compares predictions from all of the algorithms to see which one worked best. Basically, your job is done now. The IT folks who had gathered around begin to disperse except for a couple of people who linger so they can see how you'll save and store the winning model. Select X to close this window and continue. 2. You have two options. You can save the model or you can save as a notebook. To use the model again in Watson Studio you would select Model, but to interact with the model on a deeper level you need to save it as a notebook. Select Notebook. 3. The name shown in the name field in the Define Details section will change to the name of the model and the pipeline that Watson selected with Notebook at the end. Select Create. 4. Now, select the View in Project link that displays in the notification box. 5. The pipeline notebook displays, but it is currently view only. You need to be able to edit it. Select Edit icon from the menu on the top right. This makes it possible to edit the notebook. 6. The notebook in an editable form displays, but it is not trusted. This means that the JavaScript shown in the notebook will be disabled and not allowed to run. Since you want to be able to run the code, you need to trust the notebook. Select the Not Trusted link in the upper right. 7. This displays the Trust This Notebook dialog box. Select Trust. 8. The display refreshed and the notebook now shows as trusted and all the JavaScript in the notebook is enabled. Select the next arrow to continue. 9. Now that your notebook is trusted, it's time to download the notebook. Select File from the top menu. 10. Now, select Download As. This displays the formats that you can download the notebook in. 11. Select Notebook.ipinb to download the notebook in Jupyter Notebook format. 12. This will open a new tab and automatically download the notebook in Jupyter Notebook format to your computer. Next, you'll look at what you can do with the downloaded notebook. Conclusion: you successfully saved and downloaded your IBM Watson AutoAI model. You can now use this model with new data sets, modify the code of the model, and even use the model on other integrated development environments, IDEs. You've done a great job. You've saved the most effective model so it can be used with additional data sets in IBM Watson Studio and saved it again as a notebook in which you can see and edit its code and algorithms. This was probably the easiest part of the work for you to share with your colleagues. But, they still want a quick review of the steps involved. So, you take a few moments to run over it with them. You share the following. You saved the best model so your colleagues and try it out on new loan default data sets, getting results that could be immediately useful to the bank. You also saved it as a notebook in which it's possible to edit the code behind the model, add new algorithms, and more. You've downloaded that notebook in Jupyter Notebook.ipinb format. It's been quite an adventure. You've helped a major bank improve their risk management, not only creating a model that they can start using right away, but also showing their IT experts how they can start developing more great models in IBM Watson Studio. You've done a great job. You've completed your initial setup and are ready to create the actual experiment. You provisioned IBM Watson Studio as a service. You created a new project. You uploaded the data about past loans and defaults that you'll use for machine learning training. Let's review your steps with a short quiz to remind you of what you accomplished. You've come so far and learned so much. You had the opportunity to create 4 versions of an AI machine learning model in IBM Watson Studio, train them all on the same data set, then test them competitively to see which one predicted the most effectively. Now that you've completed this course, you should be able to describe machine learning algorithms and models. Explain the purpose of IBM Watson Studio. Describe the key features and benefits of IBM Watson Studio. Set up a machine learning project in IBM Watson Studio. Create a cloud object storage resource. Import a data set into IBM Watson Studio. Build an AI model using AutoAI in IBM Watson Studio. Run a prediction experiment for an AI model. Explain the confusion matrix. Save a model as a Jupyter Notebook. Download a notebook in Jupyter Notebook.ipinb format. Key points to remember. 1. IBM Watson Studio is an integrated development environment, IDE. 2. It was developed to solve problems that development teams experienced in communication and project coordination. 3. It has the capacity to construct, provision, run, and test machine learning models. 4. It can save its results as working models or as editable notebooks. 5. You had the opportunity to practice in simulations of IBM Watson Studio 2. Provision the Watson Studio service. Set up a new AI machine learning project. Import bank loan risk data. Create 4 machine learning models. Train these models. Run them competitively. Identify the model that most effectively predicted bank loan risk. 6. You considered a client's business need, then created and tested an AI solution that could meet that need. Explore more. If you'd like to learn more about IBM Watson Studio and its AI project capabilities, check out these resources. Opens in a new tab. IBM Watson Studio opens in a new tab. Explore ways that IBM Watson Studio automates the AI lifecycle and learn how it can manage AI model risk. Confusion Matrix opens in a new tab. Deep dive into the confusion matrix on Wikipedia to see how it tests AI prediction results by visualizing a model's performance.